All right, so as we move forward in this unit, the molar mass is going to be the foundation of a lot of the calculations and topics that we're going to talk about. So now we're going to move on to percent composition. You've probably dealt with percentages in your math class, but just a quick review. When we talk about percentages, we're talking about how parts of something compare to the whole. And when we talk about the whole, we're just saying if we put all of the pieces together, that constitutes the whole. The equation that we're going to be using for percent composition is percent is going to equal part divided by whole times 100. For example, if we look at this little pie chart on the right, it asks what percent of the circle is red. So we figure out our whole. We have 1, 2, 3, 4 total pieces. So that means our whole is going to be 4. And we see that only one of the pieces is red. So the part is going to be 1. If we plug those into our equation, 1 part over 4 for the whole times 100 gives us 25%. But in chemistry, when we talk about percent composition, if I can move on to the next slide, we're talking about the percent composition in a compound. So in our first example, we're going to look at what is the percentage of chlorine in magnesium chloride. So our compound is MgCl2, and we need to figure out the part in the whole. The part is always going to be the element. The whole is going to be the compound. Sorry, and by that I mean the mass. So first, we need to find the molar mass of the entire compound. So just from our last lesson, we list our elements, magnesium and chlorine. We have 1 magnesium and 2 chlorines, again, given by the subscripts. We go to our periodic table to see that magnesium has a mass of 24.305, which we can round to 24, and chlorine has a mass of 35.45, which we can round to 35. 1 times 24 gives us 24. 2 times 35 gives us 70. Again, our units are grams per mole. We add these together and we get a total mass of 94 grams per mole. And again, this is going to represent the whole. Our problem is asking us for the percent of chlorine. So we're going to focus just on chlorine, and that's going to give us our part. So percent chlorine is going to equal our part, which is 24, because that's the mass of chlorine. That's magnesium. I messed that up. This is not our part. We're looking for chlorine, so this is going to be our part. My apologies. So our percent chlorine is 70. If you were doing magnesium, then you would use 24. Our whole is 94, which is the molar mass of the entire compound. Our units cancel out, times 100. And I'm just going to type this in my calculator really quickly. We're going to do 70 divided by 94 times 100, which will give us 74.5% chlorine. Again, we could very easily figure out magnesium. We know that a percent, everything has to add up to 100 to be the whole. So we would just take 100 minus 74.5. So that means percent magnesium would equal 25.5%. Second example, how much of calcium hydroxide is composed of oxygen? So we're going to do this the same way. Calcium hydroxide, let me make sure I wrote that correctly. Yes, calcium hydroxide. First, we have to find our whole, which is the molar mass of the entire compound. Calcium, oxygen, hydrogen. We have 1 calcium. Our 2 gets distributed to everything inside the parentheses. So 2 oxygen and 2 hydrogen. If we look at our periodic table, calcium has a mass of 40, oxygen 16, and hydrogen 1. We multiply 1 times 40 gives us 40, 2 times 16 gives us 32, and 2 times 1 gives us 2. We add it all together and get 74 grams per mole. Again, this is going to represent the whole. We're looking for percent of oxygen, so oxygen right here will be our part. So percent oxygen will be our part, 32 grams per mole, divided by the whole, 74 grams per mole, times 100. Again, I'm going to type this into my calculator really quickly. 32 divided by 74 times 100 gives us 43.2%. And that is all we have to do for percent composition.